X is itself. So we know that E is some sort of a constant which is called the Euler's constant. Okay, so in this section we are going to prove that its derivative is itself using the limit definition, which states that the derivative of f of x is equals to the limit of f of x plus h minus f of x over h as h approaches 0. So let's try to prove that the derivative of e raised to x is itself. So let's try it. So let's say that our function is e of x. So let's try the limit of e raised to x plus h minus e of x, because we add h to the variable like in this section, minus the function itself, which is e raised to x over h as h approaches 0. So one quality of this term e raised to x plus h is that we can separate it. That's one of the beautiful qualities of exponent. When they are in addition, you can do this. And they have the same base. Okay, so let's try to apply that on our here we go. So what can we see now? I have realized we can factor e raised to x out since it does not contain the variable h. So it will not be affected by the variable h. That's why we can just take it out. Okay, now it gets surprising or fascinating. So when we factor out, we remove that, and this becomes 1 over h. So what fascinating is that the e raised to x is now segregated to a constant, to some sort of constant. See? So to prove that the derivative of e of x is equals to itself, this sort of constant must be equal to 1, so that e raised to x times 1 is itself. So we must prove that. So we don't want our function to get undefined, so let's use 0.00000001 so that it will not get undefined, since our intent is as approaches to 0, not equal to 0, as h approaches to 0. So when we are to apply that, e of x multiplied by, so we remove the limit since we are substituting now, 0.00000001 minus 1 over 0.00000001. So if we are to enter this on a calculator, we can get 1.0000000 minus 1 over 0.00000001 if you are to enter that on a calculator. Oh, so 1.00 minus 1 will be, of course you remove the 1, it becomes 0. E of x multiplied to 0.00000001 over 0.00000001. So the quality is that if something is divided by itself, it becomes 1. So that's why the derivative of e raised to x is itself. Because if you are to apply the limit definition, this is what happens. You see the proceedings. Okay, so now we have proven that the derivative of it is itself. So this mark means that it is now proven. So thanks. So yes, the derivative of e raised to x is itself.